Hello and welcome to part 8 of the UBIK solution. In this video we're gonna rotate the upper arms, and by that I mean these two joints out here, and right now we place them in a fixed initial position or location, and what we're gonna do now is to allow them to rotate independently or distinctively from each other. And yeah, so for that, we're gonna, if you want to read the paper or the theory behind it, it's found on page 12 of the thesis here. This is a basic explanation, and if you're more into how it's actually implemented in the Unity solution, you can open it up yourself and see if you can decipher it. But otherwise, I'm going to go through this part here. It's basically mostly one-to-one to relative to how Matthias Paje did it. Okay, so I want to go inside the component. Actually, that's not the component. This one. And actually, let me just return to the paper here. As you can see here, we have to get a notion of an arm length here, and we're also going to have a scaling constant, which you will find here in the equation, and we will have something called a distance ratio threshold, along with a distance ratio. So we're going to get into that in a moment, but just know that we need to figure out how to define the arm length. So right now, the only distance we really have is this upper arms distance, and that is this is the distance between these two joints here. So what we need to figure out now is fit this in. It's a distance between my hand and my upper arm joint here. So that's the entirety of this distance here. The way to calculate that is to take, most people or implementations I've seen, or a lot of people have done it this way by asking people to stand in a T-pose, and then it measures the distance between the arms. Some also just say you stand up, straight up, and then press a button, and then it measures your height. And because the distance between your height and your arms are basically almost the same, that's one approximation. So we can use that knowledge to our to come up with a distance here. So we're gonna in the VR character here, we're gonna create a begin event or begin play. And here we're gonna call a Calibrate function on the UBIK component. We don't have it currently, so we have to implement that first. And that distance I talked about just now is gonna be a float, and let's just call it distance. Actually, let's call it height, because that is more or less what it is. And if we compile this and call it, you can see we get something like this. And if I just enter my height in centimeters, it's going to be 182. I think in my younger days I was 184, so I'm just going to give it that because it feels a little bit more correct. Anyway, let's jump into the Calibrate function. So we have three values we want to generate for this specifically. Only actually we just need one currently, and that is the arm length itself. And since we have the height, we can divide that by 2. That is going to give us the half distance. So if we just say the height is the same as the wingspan, so divided by 2 is going to give the midpoint here. So if we then take this this height here and subtract, I believe, let me think, if we subtract, actually it should be done first. We subtract the upper arms distance. So there's a 32, and then divide that by 2. That is going to give us an arm length. Promote to a variable. I'm just going to print it out on the screen and see what value we come out with. So 76 it said. I think, as I remember, this is a bit too high according to how I think it should behave. I actually think, let me just check something. Yeah, actually what I did originally was, and I think that is what they did also, or he did, was to divide the height first and then afterwards subtract the upper arm distance. That would give the arm length, that it should be more close to 60. Yeah, 60. So let's go with that for now. We also need to calculate later on the upper arm length and the lower arm length, but that's for later. Let's just save it for now. So let's return to the logic in question that we want to work with. It's the set upper arm, and last time we created this part here. And what we also need to feed in this function here is a hand. So since we're inside this set left upper arm, we want to set or feed in the left hand effector in shoulder space. So the one with the S here. So this function here, rotate upper arm, and it needs to also take in a hand transform. Technically just the vector really. Let's just do a vector. Oops. Okay, so let's go back, and then we can split this one open and then just feed in the location here. We do the same for the upper arm, and we take the right hand effector S for shoulder space. Okay. So with that, just going to check. Yeah, we are going to take this part here and disconnect for now, because this part here is going to go all the way down somewhere here. Maybe not that far, but somewhere over here. Just gonna park it for now. And this is gonna be we're gonna promote this to a variable and call it the initial shoulder position, or initial upper arm position. So this is the point we saw before when that was rotating fixed around the shoulder point. That is that location that we have here. And we have the hand location here now. And what we need now is to take the initial or the hand location and subtract. So it's actually the other way around here. We need to take this one minus the initial upper arm position, like this. Yes, and that is going to be a hand to shoulder direction, hand to upper arm direction. So what we're going to do now is to create two ratios. One is called the forward distance ratio, and the other one is going to called the upwards distance ratio. So they are both based off some fixed vectors, and because we are in shoulder space, we can just safely use the vector forward. and the vector up. So let's move this one a little bit out of the way. So what we are basically going to do now is to dot product these two against each other to get an angle, sort of. So this is going to give us an angle, but since we divide this by the arm length, which we just derived from the height, this one, so this is divided by the 60. So depending on how long arms you have, this is going to give us a ratio between, yeah. So promote this to a variable, call this the forward distance ratio, and we do it similarly for the up vector. And call this the upward distance ratio. All right. So for now, then we make a sequence, because we're going to do a few things here first. First, we're going to take care of the forward, then the upwards, and then we're going to figure out what rotation or transform to return in the end here. So the only thing we can safely just fill out for now is going to be this. We have the location already. That is going to be the initial arm position here. And because this is the fixed position and we are in shoulder space, what we can do in order to get the shoulders, because what we are actually calculating now is the reverse location. So what we need to do here is invert this, and that will give us the correct position. So this will make sure that this moves instead of it's being fixed. I hope that makes sense a little bit in a way. So we don't have the rotation that is what we're going to calculate now. And here I would suggest you refer to the thesis paper to figure out what fixed values the Matthias Parcher he used. I'm going to use, I think, the same values and try to explain what happens here. So for the forward distance ratio, this is actually split up into two. So there's going to be a check if it's the hand is in front or behind the shoulder joint. And that means that it's going to rotate according to this joint here. It's going to rotate forward quite a bit, but it's not going to rotate very much backwards. So we check if this is less than 0 or greater than 0, and then we take this forward ratio and we subtract a little fixed amount, and in this case I think he chose 0.5 if I'm not mistaken. And then the idea is you multiply this by a constant, a scaling constant, and we can, just for simplicity, I don't think that's the way he did it, but for simplicity here, we're just going to use it exactly same values both for the up and upwards and the forward ratios and limits. But you should definitely consider splitting them up separately. So distinct shoulder ratio multiplier. And I believe this was originally set to 20. But just so we can easily see what happens, I'm going to set it as far up as 50. So we can actually see something happening. And then the idea is you want to clamp this so the shoulders don't completely go whack. You clamp this to a maximum. So promote this to a distinct shoulder rotation limit. Distinct ratio. This is actually ratio multiplier. This is rotation multiplier. Sorry. And this is rotation limit. So I believe it was set to 33. So for now we can just choose this. I think it's okay. Otherwise we'll just tweak it. And then let's just try and set this to a yaw like this. Might have to change this into a vector, but let's try this for now. Okay, so if it's below 0, we want to do this a little bit different. So for now we can just copy this, and he uses a different offset here, so he minus 0.08, and this is going to be the same. And then the clamp is going to be the opposite way. So instead of clamping the max, we're going to clamp it to the minimum. So we take the same limit, but we multiply this by -1. Like this, and I think this should be 0. And then we set the yaw here. This is if the hand is behind the back, behind the shoulder. Okay, and then we need to figure out what to do with the upward, and that is very similar. We take the upward distance ratio. Let's just copy all the stuff up here. And here we use a fixed value of 0.2. Again, just pick them from the Unity code, or yeah, basically just experiment with them yourself. Okay, and here we create a new variable, local variable, and call this the roll. And this is going to be clear in just a moment why we call this the roll. Like this. I think this is correct. Yes. So we have a rotation now. We need to set make rotator, and depending on if it's the left or the right arm, we might need to take, and I think we need to switch these around. For now, let's just plug them in as they are here. So we put these into the roll and the yaw, and this is a good place to test. I'm just going to hit simulate and see what happens. So the first good thing is that the one tiny bad thing is that actually it seems like the green arrow is now pointing the wrong direction. So I guess I need to switch this one. Let's see if this is correct. If I move this one, okay, that's definitely not right. Huh. Okay, so it seems like we have a bug. The roll, no, okay. I switched them around. Okay, so when we move forward, you can see after a certain point it starts to move with the hand. and if we move upwards, it moves upwards, but it doesn't move downwards. And it does move backwards also, but way too much. So I guess we could try and fix or tweak this, especially the back part here. But as I mentioned, these values are way too big, so normally you would set something like this 20 here. That means it's gonna be a little bit less. And you can play around with these values anyway yourself and see what fits the best. Alright, so let's test it out also in VR. Okay. Hello. Okay, I'm missing one more thing, because actually I forgot the chest or the shoulder. We're not. I set it to be exactly the same as the head rotation here, just to simplify things. So we're inside the set shoulder function right now. So make a rotator and just isolate the yaw from the head. Otherwise we're gonna get some weird shoulders or weird shoulder joint. And we're gonna revisit this anyway very soon and come up with a way to set the shoulder. So now we have the yaw only here from the head. So that means that when I'm tilting my head from the side to side, it doesn't move. But if I turn like this, the shoulders move. If I move my hand, fuck. What? Okay. Right. If I move my hand, I was gonna say forward, it should rotate backwards. So I probably need to multiply this. At least the yaw, I guess. Maybe also the. Okay, let's try this one first. So inside the rotate upper arm, we have this, and now we also make sure to rotate and pick A. This is left. So notice how I use a parameter as a variable like this. I don't have to draw it all the way from up here. It's just supported, but it does have some implications if you copy things back and forth. Sometimes it loses its connection, but yeah, in this case it works. So let's see if that fixed it. So it looks like it's, and you can see it's moving. This one is correct. It looks to be correct. It's a bit hard to see with this small value. I'm just gonna take this part here and then copy this. Like this. And we're also gonna, just for the sake of clarity, take this and up it to 50. So it's a little bit easier to see, but definitely remember, definitely want to set this a little bit lower. So you can see now it's moving upwards and forward. Also, you can see it from the side here. It's moving forward, and I'm looking in the mirror now. It's moving forward when I'm at a certain point here. When I'm moving my hand back, it's also gonna move a little bit backwards. but it's not going to go down. If you want it to go sag down, if you want to let your shoulders hang, kind of, you could implement a similar logic. But I believe the Matthias Parcher, he didn't do it, so I actually also didn't do it in this particular case here. So I'm just going to finish off this video here by setting the value back to 20 and just make sure it's not a complete mess. But it looks pretty okay for now. Yeah, actually what I'm going to do is I'm going to comment these 0.5 in case you want to change them and experiment with different values. Then it's always a good idea to comment them at the top, then you can easily get back to it at a later stage, like this. Let's see. So we managed to make a very simple calibrate function, and we also managed to set the upper arms rotation at the moment. And I believe the next thing we should tackle, or at least address in some way, should be how we create a better rotation for the shoulder, or what is going to be the basis for the chest at some point. Because as it is right now, we let the head rotation control the upper body, as you can see from this. So this red arrow here I'm pointing at right now, this is the chest orientation, and as you can see it's following the head orientation completely. That is not what happens normally. You are able to turn, and you will turn your head normally without turning your upper body. So we need some other way of doing it. I will get back to that in the next video probably, and might have to split it up into two videos depending on how difficult it will be. But let's get back to that later. For now, thank you for watching, and hope you enjoyed. See you in the next. Bye.